So now in this problem over here, what we're going to do is we're going to we're going to prove that a cube minus 6a square plus 7a plus 2i is equal to 0. So we have the value of a given over here. So what we're first going to do is we're going to find the value of a square. So we know a square is equal to a into a. So we're going to multiply the a matrix into the a matrix. So let's just substitute the values of the a matrix into the equation over here. So in the end, what we're going to do is we're going to have to multiply these two matrices. So to multiply two matrices, what we have to do, suppose you take the first row from the first matrix and the first column from the second matrix and multiply both of them together. And you're going to get the first element over here, which is, as you can see, 1 plus 0 plus 4. So to get the second element, what we're going to do is we're going to multiply the first row and the first matrix and the second row from the second column from the second matrix, sorry. And you're going to get 0 plus 0 plus 0. So we're going to do this for every single element, and we're going to get the final matrix as this matrix over here. So this is going to be your a square. So next what you have to find is a cube. So we know that a cube is also equal to a square into a. So we're just going to substitute the value of the a square matrix over here and the a matrix. So we're going to get an equation that looks something like this. So what's going to happen now is we're going to do the same thing which we did in the a square matrix. We're going to multiply both the matrices. So to multiply, once again what we're going to do is we're going to multiply the first row from the first matrix and the first column from the second matrix, and we're going to get the first element over here, which is 5 plus 0 plus 16. So similarly we do this for every single other element, and we're going to get every other element. So once we've solved the matrix, what we're going to get is a cube is equal to this matrix over here. So we have the value of a cube now. So everything we need to solve the question's already been taken. So what we're going to do is we're just going to solve this problem. We're just going to take all these a cube and a square and a, we're going to substitute it into your equation. So the equation is a cube minus 6a square plus 7a plus 2i. I over here is an identity matrix. So now let's just substitute all the values. So on substituting all the values, you're going to get an equation that looks like this. So let's just multiply all the matrices, all the elements, like we're going to multiply 6 into a square and 7 into a and 2 into I. So after multiplying all of these, what we're going to get is an equation like this. So first we're going to add all the matrices together, and then we're going to subtract all of them. So on adding all the matrices, we're going to get this matrix over here minus of the other matrix, which is 6a square. So what we're going to do is we're going to minus, first add the matrix. So on adding the matrix, we're going to get this matrix which has the values as 30, 0 and 48 in the first row, 12, 24 and 30 in the second row, and 48, 0 and 78 in the third row. So as you can see, both these matrices which we're subtracting are the same. So when you subtract both of these matrices, what we're going to get is a matrix which has all terms as 0. So when the matrix has all the elements as 0, we're going to the whole value is basically going to be 0. So this is what we had to prove. This is your RHS value. So now we prove that the LHS is also equal to 0. So your LHS is equal to your RHS. So that's what we have to prove. So that's basically our answer. So basically what you have to know is how to get the value of a cube and a square. So if you're going to have a square, you just have to do a into a. For a cube, it's basically a square into a. For a power 4, it's basically a square into a square. So that's how you have to do this problem. It's really easy.